Okay, so let me talk about the philosophy of the equations of motion. So, equations of motion, let me write first of all the equations of motion here. There is first equation of motion which you are very familiar by now. This is acceleration is equal to change in velocity divided by change in time, which means that Vf minus Vi over change in time delta t. This is equation number one. Yeah, so this is one equation of motion. We already know this equation of motion from our previous chapter. The second equation of motion is this: delta x, which is displacement, equals to Vf plus Vi over 2 multiplied by delta t. This is second equation of motion. Now these two equations of motion are called fundamental equations. These are called fundamental equations, right? Okay, now why they are called fundamental equations, we'll talk about in that in a minute. So I probably should write this part nicely. It is delta t. Yeah. Okay. Other two equations are these. So these are fundamental equations. The other two equations are these. So delta x equals to Vi multiplied by time plus 1 over 2 a t squared. This is equation number 3. And the last one is V square, or rather V f square minus Vi square equals to 2a delta x. This is equation number 4. These equations are called derived equations. These are called derived equations because they are derived from the fundamental equations, right? So these two equations, equation number 1 and equation number 2, these are fundamental equations. And equation number 3 and 4, these are derived. They are derived from equation number 1 and 2. Now question is that why equation number 1 and 2 are fundamental equations? You are already familiar with the equation number 1, how you obtained that. Yeah, do you remember that how you obtained equation number 1? Well, you plotted velocity time graph. Yeah, this is velocity time graph, and in this velocity time graph, how so your velocity is along vertical axis, time is along horizontal axis. Velocity is measured in meter over second, time is in seconds. Okay, so now how do you calculate acceleration? Well, you calculate acceleration by calculating the slope of this graph. So I choose any 2 points here, and I then draw a right angle triangle, and I multiply this part, which is called rise, with sorry, I divide rise with this part which is called run. Yeah, so your rise over run comes out to be delta V over delta t, which is the definition of the acceleration. This was your equation number 1. So why equation number 1 is called a fundamental equation? Because it is derived, because you obtained that equation directly from the velocity time graph, right? Now this velocity time graph, if you look at this graph carefully, it started from here. It started from this point 0 origin, where time is equal to 0 and velocity equals to 0. and it increased, your velocity changed constantly in this direction. Yeah, but what if my graph, velocity time graph, is like this? So again I'm going to have time in seconds along the horizontal, velocity in meter over second along the vertical axis. My graph begins from here, right? So what do I do if I want to calculate the displacement? Yeah, in this graph, if I want to calculate displacement, I will calculate area under the graph, and area under the graph, let me do that with a different color. Yeah, so area under the graph would be this. This would be area under the graph. How would you calculate this area under the graph? You will calculate the area of a right angle triangle, which is 1 over 2 times base, which is this, multiply by height, which is this. Now if I ask you that calculate the displacement from this graph, what would you do? Of course you will do the same thing that you did in the previous graph, and you will calculate area under this graph, and that would be this. This will be area under the graph. And how do you measure area under this graph? Well, this is not a right angle triangle, this is not a rectangle, this is not a square. What is the name of this shape? This shape is called trapezium. Yeah, and what is the formula for the area of a trapezium? Formula for the area of a trapezium is 1 over 2 into sum of parallel sides multiply by multiply by the normal, yeah, um, or perpendicular side. So let me write it normal because it would fit in hopefully on this page. Yeah, so if I calculate the area under this trapezium, that area would be equal to the displacement covered. So my displacement would be this. Then I would write 1 over 2. And what are two parallel sides here? Let me choose a different color. What are the two parallel sides? One parallel side is this, and the other parallel side is this. Yeah. What is the value of velocity here? 0. What is the velocity here? This will be called initial velocity, and because this is the velocity where we started our observation, so this point is called initial velocity. And what is this point called where we end our observation? This point is called final velocity, right? So what is the first parallel side? First parallel side, length of first parallel side is this, vi minus 0. That means one parallel side is vi only. And sum of two parallel side, what is the second parallel side? That is vf. So this length, I want to measure this length. So vf minus 0, second parallel side is vf minus 0, which is vf, multiply by what is the normal here? This is the normal. Yeah, and it is equal to what? Normal is parallel to time, so it is delta t. So delta x is equal to vf plus vi, or vi plus vf divided by 2 multiply by time. This is your second fundamental equation here, this one. Yeah. So why these two equations are called fundamental equations? Because you have obtained them directly from the velocity time graph. Yeah. And how do you obtain the derived equations? You make certain substitutions here and there, and then you get your derived equations. Now I'm not going to discuss how you get derived equation. You will certainly discuss that in next semester, but in this semester we will just discuss that these equations are obtained, equation number 3 and 4 are obtained from 1 and 2, right? I'm not going to discuss how, but you will discuss it next semester, yeah, when you will study uh, rather higher advanced physics. Yeah. Now this quantity, I want to discuss this a little more. This quantity, which is Vf plus Vi over 2, this quantity is called average velocity. So remember, you obtained average velocity from velocity time graph, or from sorry, not velocity time graph, from displacement time graph in the previous chapter, right? And so if you have a displacement time graph, from that displacement time graph you can obtain average velocity. But if you don't have a graph, then how do you calculate average velocity? You use this formula to calculate your average velocity. Now the last thing that I want to describe here in this video is that all these equations of motion, that you have discussed here, 1 2 3 4, they are all valid only. So these equations, I'm going to write here, these equations are valid for constant acceleration only. Constant acceleration only. Yeah. If you have a constant acceleration, when would you have a constant acceleration? You will have a constant acceleration when your velocity time graph looks like this nice straight line. Yeah. Or your velocity time graph looks like this nice straight line. If your velocity time graph looks like this, then you cannot use these equations, because here your acceleration is not constant. How would you calculate acceleration here? You know that you will calculate acceleration by taking any 2 point, and you will calculate acceleration here by joining these two lines. Or if you want to calculate acceleration between these 2 points here, let's say point 1 and 2, then you will join these 2 points here. Now acceleration between 1 and 2 and acceleration between 2 and 3, they are different. Similarly, let's say if I want to calculate acceleration between 3 and 4, this is point 4, this is different acceleration. I'll join these two lines, this acceleration is different. So that means here acceleration is not constant, and therefore I cannot use equations of motion in this situation. I can use equation of motion only in this situation where my velocity is increasing uniformly and I have a constant acceleration, right? So let me know if you have any question regarding the equations of motion. We'll do more practice in our regular lectures. Okay. Thank you very much. See you later then.